we're the second crushing system idea. So this is the kind of general, you can see the picture and then it's right here. So it's a pretty simple concept. We have a rolling barrel, which our alpha prototype doesn't actually have the teeth, but it should have teeth. We have our mock-up on another computer because we were having some technical difficulties, but it's a hard to see, but it's a roller with teeth against a plate where the rocks will go in to be crushed.
Essentially, the barrel that you see will have 3/4 inch by 3/4 inch stock in the lengthwise direction all the way around. Can you see from here, anybody, or no? I don't know. It's kind of hard to see, but essentially there's going to be a bracket on either end of the barrel itself it'll have kind of like a star-shaped pattern all the way around that will hold each key stock in place. And then you can take off the bracket from either side and remove the key stock to be replaced.
Okay, so these are unknown assumptions that we had to test to make sure that they are true. Some tests are ongoing, some tests we have done. So our assumptions would be that our crusher has enough force to crush a rock that they will be crushing over there, that the rocks will come out of the hopper at the desired size and not come out too small, that our material is strong enough to withstand crushing and for at least a long amount of time without failing. And lastly, that we assume that we will need teeth on the crusher for it to pull the rocks down the hopper, and that was tested as well.
So, regarding how much power is required to crush these rocks, we looked at more scale in terms of hardness for what steel can handle and what white marble can handle, which is what they gain the most money from in their product. So, more scale for, this is just research, more scale for that, white marble is 3 to 4, and for stainless steel, which we won't necessarily be using, we'll be using regular steel, but it's about 6.5. It's not too much of a difference between stainless and regular steel. For our other question, or our unknown, was do we actually need teeth? Because adding teeth to our barrel is going to make it a lot more difficult. So we did something. We named it the cough drop test. Now, if you look over there, you can walk by it as you in class today, is a broken up cough drop. And that did not go easily. We dropped a cough drop right in through our plate and our barrel, and we started spinning this, and it would not go down. Instead, it would just kind of spin there or just not go anywhere. So Emma was kind enough to take a ruler and kind of just jam it down, and it became powder. So we need teeth, to something on the barrel to grip onto whatever is coming through and bring it down. Now, the reason why Jake was explaining the way it was, we don't want the barrel to be the thing that wears down the most. We want the stock, the teeth, to get most of the wear. So the teeth would be the thing that would be replaceable, and you would keep this, which is most likely going to be the most expensive piece, safe in most of the time. And we are going to do another test called, we don't have a name for it, but just so that we can kind of confirm this, Professor Chen recommended we could just start dropping rocks from different heights. We are going to find some white marble. There actually is some at Walmart. They're chips, but we'll see if we can find bigger pieces. But see what force is required to actually break white marble.
I would make it clear, so to drop some weight to a marble, not just drop.
Drop some weight to a marble. That's much better.
Right, I'm not sure.
I thought you meant drop white marble. And we're going to be on top of the roof. Just
All right, some of the things we learned, that we're going to have a lot of force when we get the actual teeth crushing. Once we got the cough drop into the design, it just obliterated it. So we think that getting the amount of force that we want in there, this wheel is going to pick up a lot of inertia, and it's just going to pretty much obliterate anything we think we can throw in its path. So I think we're good, and regarding any teeth to grab it and put it in there, we want to double check how much damage we're going to do to the teeth and everything. But we're pretty confident that we're going to have more than enough force to get this wheel spinning, and then just grab anything and pull it right through.
Yes.
one, what do you think is the estimated wear for the teeth potentially?
Oh yeah, that one was not.
That's something we're going to be testing.
And second one, when you crushed the cough drop, did the powder go to like a pretty concise area, or was it kind of everywhere on the?
Well, in our test, we actually kept the wrapper on.
Yeah, as I say, we weren't necessarily testing for the
It wasn't
size, we
just
were
the top.
testing would it go through without teeth.
But, you know, we do have extra cough drops. We can go without the wrapper and see where all that powder is.
Use all of my cough drops.
How was the teeth attached to the rollers?
So the actual barrel will have essentially a star pattern to it, so it won't actually be round. So
It'll be jagged.
so the 3/4 inch stock will kind of sit inside of it. So half of the stock will be inside of the barrel, and the other half will be retained with the other star-shaped pattern bracket that I was talking about that kind of slides over the ends. So again, the barrel is not actually going to be round. The barrel will be star-shaped, so the key stock will slide into it, and then the key stock will go all the way around, so the outside will also be kind of like star-shaped.
Yes.
How do you adjust the size of the box of the outlet?
So that's going to be one of our next steps. But one of our thoughts was making either the barrel or the plate itself adjustable.
Putting like so the other thing is on the inside of the hopper, we don't want, because it's going to be crushing up against another surface besides just the teeth. So we're going to put another plate inside, kind of, so the teeth will go up against another surface, and so we can adjust the thickness of that plate to allow for different size outputs.
Any other questions? Thank you.
Thank you.